Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. We're still continuing with the financial mathematics series, and today we'll be looking at reducing balance method. And take note, this is part 8, and make sure to check out all the other parts prior to this one. So a quick recap from part 5. Interest compounded yearly for future value is given by that, where the P is the principal, R is the decimal interest per annum, and N is the number of years. Let's have a look at a quick example so that we refresh our minds. So find the present value of the future amount of $20,000 for 5 years, earning 6.5% per annum. So now, the solution. We know that the V is 20,000, which is the future value. And also we have the N, which is the number of years, 5. And also the interest rate, 0.065. We have expressed this interest rate in terms of decimals. So that's another way of expressing the interest, especially using the formula we have. Now, substituting for the values that we have, we are going to have that. And with that, then we are going to move on to simplify whatever we can simplify and make P the subject of the formula. So we are going to add 1 plus 0.065. That will give us 1.065 to the power of 5. Then we divide throughout by that so that we get P on one side and the other numericals on the other side. And of course, simplifying this fraction further, we are going to get P is equal to $14,595.62. With that, we move on to the reducing balance method. Recall, from the interest compounded yearly for future values, we had a positive, but the moment we have a negative between 1 and R, which is the decimal interest rate, that becomes the reducing balance method. So what it does is similar to depreciation. So the one that we have above would be the appreciation, which would be the value that we would normally get when we invest our money. However, for the reducing balance method is something that we would lose. That is to say, in value. It could be in terms of cars. So when a car is brand new, it's worth more, but with time, its value turns to depreciate under normal circumstances. Example 2, a new car worth $145,000 bought 5 years ago is now worth $72,500. Suppose the car depreciates by a fixed annual rate according to the reducing balance method. Find the depreciation rate and the solution. So we need to identify everything that we're given. So we have the future value V of 72,500, the time 5 years, which is N, and the P, which is the principal or the present value of 145,000. We substitute these values into the reducing balance formula. We are going to have that. And of course, we can divide throughout by 145,000 so that we have that 1 minus R to the power of 5 on the right hand side. And we see that when we divide those two, we are going to get a half. So half is equal to 1 minus R raised to the power 5. So the next thing, because we're trying to make R the subject of the formula, or rather solve for R, we are going to remove the power. 5 is the power, so we introduce the fifth root on both sides. So that's how we introduce the fifth root. And on the left hand side, when we simplify that one further, we are going to get 0.87. And on the right hand side, the power 5 is cancelled out by the root 5, so that we just have 1 minus R. And of course, solving for R, interchanging the positions of R and 0.87, we're going to get 1 minus 0.87, which gives us R is equal to 0.13. So take note, this is the decimal value of the interest rate, implying that the real interest rate is 13%. And that will be our answer. Let's look at the final example. A motorbike worth $20,000 depreciates by 20% per annum for 2 years according to the reducing balance method. Each year thereafter, the annual depreciation is 2% less than that of the previous year. Determine its depreciated value after 4 years. The solution. So, for the first 2 years, we know that the principal or the present value is 20,000 of this motorbike, and the interest rate in terms of its decimal value will be 0.2 from the 20%. And the number of years is 2 years. So we substitute those values into the reducing balance method, we are going to get that. And that would give us a V2. So I'm using V2 to indicate that it is after 2 years. So V2, the present value after 2 years, is going to be given by 20,000 times 0.8 squared. And simplifying that, we are going to get a V2 of 12,800. That is in the first 2 years. In the third year, we know that the interest rate R is reduced by 2%, implying that for the third year, the interest rate is 0.18 or 18%. The 0.18 is the decimal value of the interest rate. So now, V3 becomes 12,800 times 1 minus 0.18. And of course, simplifying that one further, we would have that. And the V becomes $10,496. Now, moving on to the fourth year, which is the final year. We also know that the R reduces further by 2%. That is to say, from 0.18, it goes to 0.16 or 16%. Now, that is the R that we're going to use for the fourth year, implying that V4 is equals to $10,496 times 1 minus 0.18. Simplifying further, we get to that, and our V4 becomes $8,816.64. Great then, so I encourage you to check out all the other playlists that we have so far, and also make sure that you familiarize yourself with some of them because they are crucial in what we are going to cover in the future. Thank you so much if you have made it thus far. Find questions and post them in the comment section. These could be questions on reducing the balance method. We'll be glad to attend to them. Thank you for watching Numbers Simplified. Don't forget to like, share, and subscribe. And remember, God loves you.